So today we're going to be finding out if there's any values of c over the interval -1, 1 that will match the mean value theorem. So MVT states that a function has to be both continuous on the closed interval and differentiable on the open interval. So first, looking at our function x cubed minus x squared minus 2x, over this interval it is continuous. We don't have any asymptotes or anything that could cause a hole, so that's checked. And then the second part is it has to be differentiable over the open interval, so from -1 to 1. So to do that, let's derive. F prime of x is just going to be 3x squared minus 2x minus 2. And over this interval, it is differentiable. So the next step we have to do is find the slope, the average slope, over this interval. And to do that, we would do f of b minus f of a over b minus a. And in our problem, f of b is f of 1 minus f of -1 over 1 minus -1. So f of 1 in this case is just going to be -2, while f of -1 is 0, so -2 minus 0 over, and then 1 minus -1 is just 2. So this makes us have our c, not our c value, but the slope is going to be -1. So now that we're here, what's the next step? We have to find out what values of c is the slope going to be -1. So to do that, we are going to set our derivative equal to -1. And to do that, we have 3x squared minus 2x minus 1 minus 2 equals -1. We're going to add -1 to both sides. 3x squared minus 2x minus 1, and that gives us 0. So what we're going to do now is we're going to factor and solve. So we get x minus 1 and 3x plus 1. And the last thing we would do is figure out what values of x we have. So in this case, we have x equals -1/3 from 3x plus 1. And then we also have x equals 1. And looking at our interval, the only thing that could match is -1/3 because x equals 1 is one of our endpoints. So the value of c that satisfies the mean value theorem is -1/3.